Okay.
Thank you. Good morning, everybody, and welcome to the NESOI webinar on mobility. This is the second workshop, the second webinar we are organizing in the framework project. The first one was on energy plans, on electrical mobility. Let me introduce myself. My name is Cini. I am an energy engineer at NESOI partner, and I was not supposed to share this. My colleague Sarah Fox was supposed to lead. Doing very well. We share from recovery, and I'm replacing her. This event divided into three main parts. The first one is related to e-mobility challenges, so a high-level discussion on the topic. I will start with slides on general topics on e-mobility and on specific. Then we will have Sasha Jovicic, Wolfstad, presenting the topic of ferries, and my colleague Carolina speaking part of the webinar focused on the NESOI projects, the project that we are supporting in NESOI. Because for each project, we will have an introduction on the project, the best practices that we have applied in the project, and the lessons learned from the project implementation. And here we will project electrification in Antiparos in Greece, and the presentation will be done by Marios Alkinos Dimitriou and Stelios Pagouros, Daphne, and from Engineering, which are the external consultants the project. Then I did a project on e-fleet for the municipality in Tilos, again in Greece, and the presentation will be given to Tatios Kontos from the municipality of Tilos, which is the project beneficiary. And then we will present for the electrification of bus Catania in Sicily. And the presentation will be given by Salvatore Capri, production area manager at AM. And to conclude, we will have a discussion chaired by Sara Ruffini, energy engineer energy, with the participation of previously mentioned speakers.
Giorgio, sorry, but your sound is not very good. Is there an option for you to improve this?
Giorgio, you may switch off your video and perhaps the sound will be better.
Giorgio, we can't hear you at the moment. I don't know if you try to speak.
Hello?
Yes.
Oh, sorry, can you hear me now?
Yes, let's try like this.
Okay, sorry.
There is an echo there. Yeah.
Can you hear me now?
Yeah, but you need to mute one of the two microphones.
Yes. Okay. Sorry for the inconvenience. So I was saying, now we move to the first part of the webinar on e-mobility challenges and opportunities. I start with an overview. Thank you, Cecile. An overview on e-mobility. As we know, the global transition towards a low-carbon economy has started, supported by many international targets and agreements, including the most important one, the Paris Climate Agreement, and many countries in the world, and especially the European Union, are working to achieve the overall target of climate neutrality. Especially the European Union aims to be climate neutral by 2050. So an economy with net zero greenhouse gas emissions. This concerns, of course, industry, buildings, and transport. The transport sector is responsible for approximately 20% of the global CO2 emissions, and for this reason, the implementation of green transport and cleaner mobility are really important to meet the climate goals. E-mobility indeed is one of the main drivers to enable this change, provided that the energy used for electric vehicles, the electricity used from electric vehicles, is obtained from renewable sources. Next slide, please. In the NESOI project, we are supporting several e-mobility related projects. As you know, the NESOI is the European Island Facility supported by the European Commission to make EU islands becoming the locomotives of the European energy transition, mobilizing investment in different type of sustainable energy projects, and testing innovative energy technologies and approaches in a cost-competitive way. We are supporting or have supported a total of 54 projects, 40 in the first round, and further 14 that are ongoing now in the second round. And this project covers several topics, one of which is e-mobility, that is articulated in the various modes of transport. So we cover road vehicles, that includes electric car for private use, and light and heavy duty vehicle for commercial use. We have electric buses for public transport, and we also have electric ferries and boats to connect islands and to connect the islands with the mainland. Next slide, please. Electrical mobility produces benefits at environmental and social level. On one hand, by reducing CO2, so greenhouse gas, and also pollutant emissions, especially regarding pollutants, the particulate matter that is cause of serious social consequences, and on the other hand, by reducing the noise, which is also important to improve the comfort for inhabitants, users at the local level. Moreover, today, the environmental and energy policies of the international communities are dedicating a lot of investment on the mobility and transport sector, and in order to tackle the environmental challenge towards CO2 reduction and particulate emissions, investment plans are addressed to implement the paradigm of smart and electrical mobility. Next slide, please. Here we are addressing some of the challenges related to e-mobility. We need to consider specific challenges and limits. For example, the fact that the energy source must be green and renewable. Otherwise, we are just transferring the problem of generating harmful pollutant greenhouse gas emission from the vehicle to the power plant where energy is produced. The second is the time spent for charging operation, which is longer compared to the one of diesel or natural gas vehicles. And the third is battery costs that are high, but there is a lot of focus on this area in order to improve the performance of batteries and reduce the costs. Now let's move to the following slide, focused on the opportunities for e-mobility in buses. Looking at electrical buses, we can say that they are one of the drivers to make cities cleaner. Just think that a single city bus covers around 50,000 kilometers per year. then users are satisfied with the use of electrical buses because the journey is comfortable and silent. At operational level, the energy and the maintenance costs are lower compared to the thermal engine buses, and there are some opportunities available to get incentives and fundings to renew outdated fleets in public transport companies. On the other hand, in the next slide, we present the challenges related to e-mobility to electric buses. Indeed, electric buses require more space at the depot for charging station, which is a consequence of the need to increase the fleet to cover the same operational service because of the more limited driving distance compared with diesel vehicles, and because of the installation of the charging system. Then we have, of course, high capex for the vehicles and charging station, and for the battery change after around 10 years. Although, as mentioned before, research is focusing a lot in this direction to reduce costs for batteries and improve performance. And then, to conclude, there are costs to be considered for adapting the electrical substation at the depot to allow simultaneous charging operation or to provide the needed power for fast charging operation along the line. Now we can move to the next slide, which is on ferries. So I invite Sasha to present these slides. Thank you, Sasha.
Yes, hello. Thank you, Giorgio. Hello, everybody. Welcome to our presentation. I will speak briefly about the e-mobility aspect of ferries. So basically, I think we can start with the opportunities. The opportunities here are very similar to the ones that we already discussed for the buses. So basically, as you know, the sea transport is very CO2 intensive. So e-mobility in ferries and e-boats can contribute to this significantly by creating a really zero emission sea transport system. There is a reduction in fuel consumption and maintenance cost, definitely a significant consideration when designing e-boats and e-transport on the sea. Reduction of noise outwards, but also reduction of the noise for passengers, which means basically that the e-boats have a much better performance when we talk about noise and vibrations for the passengers. What we also have are incentives for funding this transition towards e-mobility. What's not on the slide, what is also very important, is that most of the countries, or all of the countries that we have covered, have some shipbuilding tradition. It is an opportunity for specialized small shipyards to develop their own boats. It's also an opportunity for various participants in the value chain to contribute, from designers, from material suppliers, to contribute to the transition by participating in this. Another important aspect is basically in countries which have tourism, which are highly touristic, especially in the Mediterranean. This is a good opportunity for green branding. So in the discussions that we've had with our beneficiaries, most of them have expressed a high degree of interest to introduce e-ferries as kind of a contribution to the brand of the island as a sustainable destination, as a destination that cares about the environment. It builds into their picture that they are otherwise trying to build with other elements, such as energy supplies of hotels, car sharing system, bike sharing systems. So in aggregate, this is a potentially very valuable contribution to branding as a green destination, and something definitely worth considering. Next slide, please. The legal challenges that we are facing, or what the legal challenges which have been identified in the delivery of NESOI projects and in discussing with various stakeholders. One of the first challenges in the entire chain is the planning of the charging stations. So when you try to plan where to place your charging stations, there is sometimes a lack of availability of data on the grid capacity to be provided by the system operators. This is basically equally applicable in the mainland and in the island settings. Sometimes it is a difficult task to get this information simply because the data is not there, or the data is not properly maintained, or it's not maintained in the format that is useful for stakeholders who are trying to plan where to place these charging stations. After that, once you've been able to identify where to place your charging stations, the other important point is the property relations that inevitably arise in the planning of the system. So in most of the jurisdictions, the maritime domain, basically the area of the coast where the systems will be placed, is under special legal regime. There are restrictions on what you can or cannot build. How to basically plan the systems will depend on the various restrictions that are imposed by the central governments, by the local governments on these areas. Most typically, these areas are placed under a special legal regime, which is then assigned, which assigns particular rights to concessionaires, to port authorities, and depending on who operates the system or who develops the system, there is a need to overcome these restrictions, which means dealing with the concessionaires, dealing with the port authorities, setting up particular contractual relationships with these entities for the purpose of being able to develop and operate the boat. The third part or the third challenge that we've seen is the designing of the business model. The key question here is who will operate the lines and who will own the ferries. These entities are not always the same. We have seen that there is a wide variety of models that can be implemented in the deployment of the lines. So you can have a city communal entity, be it a public transport entity or another entity that wishes to completely own and operate the ferries. There may be a system where the local authority owns the ferries, but in some way concessions or gives operational responsibility for the ferry lines to third parties, either by way of concession or by way of other operating model. What is another complexity here is the operation and ownership of the charging stations. The charging stations will be placed on different areas, on the mainland, on the islands. It is a big question where they will be located, also depending on what we discussed earlier. The port authorities may be different in different areas, in different islands. An interplay between all of these stakeholders, the operator of the ferry, the owner of the ferry, the owner of the charging stations, various port authorities, really brings a very complex system with various stakeholders. That is something that is really worth considering when you are planning your lines and when you are planning your business model. And finally, what is important to consider is the competition with existing operators. In most countries, the operation of the ferry lines is an activity that is not free to open market, so you basically cannot perform it without a specific license, without a specific right allocated to do this. In some countries, we have seen that this is a concession, and that there may be additional permits that or agreements or tenders for the allocation of these specific rights for individual operators. So this is something also very worthwhile considering. Can you do it freely? If you cannot do it freely, what are the requirements that need to be fulfilled that authorize an entity to operate these ferry lines? there are various other administrative constraints that are very important to consider. In some scenarios, we have also seen restrictions on speed, on operating vehicles in certain areas. As you know, these maritime laws tend to be stricter in highly dense areas with very frequent ports. And then this creates a question on the feasibility of the line. People want to travel from one destination to another destination fast. Complexity in the e-boats is always the charging. And if on top of the charging line, charging time that needs to be observed, if you also have speed restrictions, then this has the potential to add significantly to the travel times. So when you are designing your lines, when you are considering the time that needs to the time that a passenger needs to get from point A to point B, this is something very worthwhile considering. This will depend typically on the interviews and on discussing with the local stakeholders, with the passengers, with the inhabitants of the islands. What are their expectations in terms of commutes, in terms of commuting time? Because everybody has a certain expectation in terms of how easy it is to get from point A to point B. Introduction of e-boats, it only makes sense if on top of the basically more comfortable line and more, let's say, steady line, you can also contribute to a more speedy transition between the mainland and the coast. So this is a very worthwhile consideration that we've seen in some areas, and definitely adds to the complexity of planning the lines. So what we've seen is, to conclude, a very high interest of islands to consider the introduction of e-boats for various reasons, but also significant legal and technical considerations that must be observed to introduce these lines in a most, let's say, straightforward and easy way. So that's it on the e-mobility and ferries aspect. I'll leave you with the buses, I think.
Thank you, Sasha, for this overview on challenges and opportunities for ferries. Now I give the floor to my colleague Carlotta Besson for the overview on road vehicles. Please, Carlotta, the floor is yours.
Thank you, Giorgio. So regarding electrically powered road vehicles, and the opportunities include cities benefit from the energy transition. Increasing the number of electric cars certainly has social benefits due to the reduction of pollutant emissions and in particular carbon dioxide for the use of this alternative technology. The reduction of noise emissions, the more comfortable vehicles in terms of limiting noise and vibrations, and reduce transport costs, energy consumptions and maintenance, and parking costs. Next slide, please, Cecilia. The challenges in the use of such vehicles and the charging stations serving them include time losses due to battery charging times and the availability of charging stations. Charging infrastructure must be distributed on the main axis connecting countries and cities. Within the NESOI projects, a methodology called the Qt theory was applied to assess whether the number of charging stations designed for private electric vehicles is sized correctly. The methodology allows the planning, scheduling, and the analysis of actual vehicle requirements. The application cases of the methodology take into account expected vehicles and thus the forecast of the number of electric vehicles that can be recharged through tourist flows and citizen electric cars. The methodology therefore represents an analysis of the territory and expected electric vehicles. Next slide, please. Among the input data of the methodology are the knowledge of the number of private cars of the citizen, the expected vehicles of the tourists, the characteristics of the vehicles in terms of battery size, average kilometers driven, and daily consumption, and finally the number of assumed charging stations. The average waiting time in hours is the output of the methodology and is calculating using a series of performance indices of the system, such as number of cars recharged per hour, number of cars requiring charging per hour, occupancy of charging stations, the probability of all charging stations being occupied when a vehicle with a low battery needs to be recharged, the average simultaneous number of vehicles in the system queuing and charging, and finally, the average number of unloaded vehicles waiting for a charging station to become available. The average waiting time confirms if the number of charging stations is adequate for the number of vehicles and doesn't result in high waiting times at the charging station. The methodology implemented at a high level allows to estimate the recharging needs of the vehicles, enabling waiting time at the recharging stations to be minimized. At the end, the occupancy of charging stations must be adjusted according to the use by tourists and inhabitants. For this part, it's okay. Thank you.
Thank you, Carlotta. So let's move to the next part of the webinar on NESOI projects. And we start from the Tesla project on chip electrification in Antiparos. So I leave the floor to Marios Alkinos and Stelios for their presentation. Please, the floor is yours.
I was muted. Thanks, Giorgio. Thank you also, Cecile, for organizing this webinar. So for the island of Antiparos, the project called Tesla was studied, and we can start next slide, please. I'm sorry, am I audible?
Yes, we can hear you.
Okay, great. Thank you. So yes, the main goal of the project was the total electrification of the transport sector on the island of Antiparos, both on land and sea. And the project beneficiaries were the municipality of Antiparos, who was also the coordinator of the project, and the Antiparos Ferry Cooperative, who acted as a consultant. Myself here today, I represent the network of sustainable Greek islands, also known as Daphne, which acted as a technical advisor to the municipality of Antiparos. And the Hydros was acted as a technical advisor of the other beneficiary, the Antiparos Ferry Cooperative. Also in the project as partners, we were aided by IRINA and the Center of Research and Technology of Greece, also known as CERT. Next slide, please. As far as the electrification of the ferry was concerned, the project focused on complete electrification of one of the 4 ferries that operate in the Paros-Antiparos ferry connection. For those of you that are not do not know the island, it is quite a small island, and the Paros-Antiparos ferry connection is quite close. So it was thought that it was a good place to start for a ferry electrification project in Greece, as every island is connected to the mainland with the internal combustion engine powered ferry. Also part of the installation of 10 EV charging stations was studied and considered, and as well as the partial electrification of the Antiparos municipal fleet, with in the total of 3 trucks, a small garbage truck, a van, passenger cars, and some 2-wheelers that will cover the need of the municipal fleet. And to power all of those, sustainably with a green power source, it was considered the installation of a 550 kilowatt peak powered PV station. Next slide, please. As far as the lessons learned by the project, we found out while studying that the cost of investment for repowering the ferry in such a way was quite high, and financially it was considered that it would need to be funded by the grants for the most part, and as well as loans. I believe it was studied that about 30% of the equity was viable to be covered by the beneficiaries. However, the project itself indeed will have a strong influence in the local community and social benefits, as pointed out in the beginning of this webinar, that the island can advertise itself as green and attract more attention to visitors by this innovative ferry line for Greece. And as well, it was also thought that it might be more effective if all of the 4 ferries were to be electrified. Although that would we would also have to take into account that the island of Antiparos is quite small, so a very large PV station would have to be considered to cover the energy needs of the electrification of both 4 ferries. So that was another aspect that we had to overcome and study. And of course, by electrifying a ferry, the footprint in terms of greenhouse gas emissions saved is very high, and the experience of using such a ferry and the trip experience of such a ferry would be quite considerably better to what people have been accustomed to. So, of course, that was another big positive footprint of the project. Next slide, please. So, for the electrification of the ferry, it was studied by the technical advisor of the ferry cooperative, Hydros, and what was studied was a tailor-made battery system for the specific ferry. And the methodology that was carried out was to gather as input the specific vessel's technical particulars, the general arrangement and size and the capacity of the vessel to receive such a repowering. The vessel's machinery arrangement, of course, was also very considered. It had to be considered as well. The available known legislation covering as far as the safety issues that have to come with repowering with batteries and electric motors of the vessel. Of course, the operational loads about the seagoing profile, port day profile, and night day profile of the vessel. The battery vendors which would provide such the batteries for the repowering, and of course the available electric power on the shore side to charge the vessel. From the set study, the output was a suitable operating scenario after the input and the boundary set by project beneficiaries, and a detailed description of the load profile and operating schedule and basic onboard installation specifications of the technical solution that was decided for the project. Next slide, please. One of the best practices of the project was, of course, the the ability to identify the specifics of the ship and the operational profile, and of course the characteristics information that we gather from the manufacturers for the ship electrical propulsion systems. As far as the technical side of the repowerment is considered, the two technical alternatives were considered. One was an onboard fixed battery room that would mean that the ship would have to charge on board during the long stays and after some round trips, and also it was considered the technical solution of a movable container battery. That would mean that after some round trips, a discharged battery would have to be swapped by a fully charged on the port side, which will also give the benefit of charging the batteries in a more flexible way, and no need to charge them rapidly and rely heavy on the system of energy system. The outcome was a detailed in-depth analysis of the available technical solutions and the operation mode of the electrified ship. And of course, by the co-stage of the project have pointed out which one of the two was the most beneficial for the project, which was in the end the onboard fixed battery room. Next slide, please. To complete the study, it was a preliminary cost-benefit analysis was carried out to assess the feasibility of the project, and the results of the analysis for the retrofitting of the ferry, together with an analysis done for the electrification of the municipal vehicle fleet and the appropriate sizing of photovoltaic generation to cover the above loads. They were examined in the context of a cost-benefit analysis to point out the economic feasibility of the project. In order to carry out the analysis, of course, the financial aspects were pointed out for how the basic financial indicators were calculated. As far as the net present value and the payback period are concerned for the project, but there were also the social and benefit, the social benefits were also identified, and there had been a monetization of those benefits, which those benefits concerned the savings of the greenhouse gas emissions, job creation of the vessel, impact on the general community of the island, and so forth. Those benefits, as well as the capex and opex of the project, and the revenues that were estimated due to the reduced cost of electricity and fuel savings, were used in the context of the CBA to point out the feasibility of the project. Next slide, please. So that was yes, that was all for the Tesla project, and we can hurry out and move to the next one.
Thank you, Alkinos. Thanks a lot for your presentation. Now we move to the project Nerida, a fit for municipality in Tilos Island in Greece, and I leave the floor to Mr. Eustachios Kontos, General Secretary of the Municipality of Tilos. Please, the floor is yours. We cannot hear you. More or less.
You can hear me now.
I don't know if it's my problem. I cannot hear you.
We hear you a little. Can you speak louder? Can you turn maybe off your camera to try to improve the sound?
What happened? It's better now.
Yes.
Okay. I cannot hear you very well. I will try afterwards. Okay. Hello from Tilos, a small island in the Aegean Sea. Can we go to the next slide, please? Okay. Our project description area of interest was water, energy, and mobile and e-mobility. Our main goal is to mature a portfolio of PV installations in the whole island in order to cover the public sector mobility and water public needs. Project beneficiary, as you can all know, is the Municipality of Tilos and the University of Attica. We were the coordinator. The University of Attica was our consultant. We have two subcontractors, one from Thessaloniki and one from Athens. And our NESOI partner was Rina and Wolf. Next, please. Our project description. I will tell you some things about Tilos. We are very good. We are very good in e-mobility as a public sector. Our fleet right now has one small passenger vehicle, two small trucks. It's wrong, and one big bus of 52 people carry on. And we have three charging stations in three different places of the island in order to charge these vehicles. One of them has a dedicated PV system on it. It's a small one, 5 kilowatts. Our annual consumption of the fleet right now is 45 to 50 megawatt hours. But have in mind that this is going to be double next year because right now we are in the process of acquiring one more bus, the same as that we have, one more electrical passenger vehicle, and three small electrical trucks. So we think that next year our estimated consumption is going to be double and a half, maybe. Next, please. Also have 8 water pumping stations, holes in the ground that give us the water here that we need in Tilos. All the stations are remotely monitored and controlled in order when we are going to open it, and we can see what is going on with them. And you can see the number down there that we have 100 megawatt hours is our electric consumption, but also this is going to be double next year because now we are in the process of creating 11 more new water pumps in the whole island. It's a big project, 1 million, that the Greek government gave us, and hopefully it's going to be ready next year by the end of 2023. So the consumption is going to be bigger. Next, please. So we have to find a way how to solve this problem because the consumption here in Tilos is going to be very, very big. So we start making two different installations, and we start having two thoughts. First was to develop a central system, a central grid-tied net metering PV station in an area that owns by the municipality, and we have a restriction that we wouldn't go up to 100 kilowatts because we are a public figure. As I told you, have already 10 kilowatts installed in the municipality. So the remaining capacity of 9 kilowatts is going to be a public body, and it's going to be by the municipality in order to have a net metering regarding our consumption, electric consumption of all this that I tell you before. It is highlighted. We have already in the NESOI project. We have already made the tendering ready to launch. When we find the necessary funds, is around 200,000 euro in order to do that small PV station of the 9 kilowatts. Next, please. The other one that we started to say that we have to do a standalone PV battery diesel configuration for our pumping stations. So in order to be, let's say, off the grid, And that's why we found 3 water stations that has the most, the annual consumption of 65 megawatt hours, the big 3, let's say. And we're trying to do a study how to put them off grid, standalone, and with that situation, PV, battery, and diesel configuration. Next, please. This is, let's say, a small map of what we've studied right now, and how it's going to be in the island. Next one. Okay, lesson learned. This is a different lesson. Have in mind that in terms of the island scale, we are a small island. We have around 500 people permanent population and around 200 visitors per day. That give us an annual theoretical population for the island of 1,250 people, if you do the math. And because of we have then that give us a lot of water that we have to consume. Also have in mind that it's a parameter that came into the picture this year, that we have a very big circular economy project regarding zero waste, and that give us has a consumption of water, many amounts of water. And because all our public services are with electrical vehicles, that gives us a very big consumption of electrical power. That's why we have to go and make a 100 kilowatts NMED PV station, and maybe that's not enough for us. That's why the development of such station, it's as I told you, because we have let's say we cannot go exceed the 100 because of the local electrical grid. Because we're in the middle of the Aegean, that gives us a very, let's say, it's a challenge for us in order to do that, in order to have the complete study, in order to have everything good, and in order to work it perfectly. Next, please. So, the best study of us is that we have made the energy studies for both what we are studying, for both the grid tied and standalone PV station. We have completed the installation study for the grid tied PV station in the scale of 100 kilowatts. That give us that we have ready all the tendering documents, tender processing, all the legislation that is required for from the Greek government, and also for the European government, which is going to be international. It's going to be international, and that gives us a toolkit that we can replicate what we have already created, in order, if the grid allows us, in order to go in more than 100 kilowatts, in order to have more tenders and more PV stations. Thank you. That was from me.
Thank you very much, Eustatios, for your presentation. Now we move to the third presentation of NESOI project on the project Best City, implemented in Catania in Sicily, focused on electric buses. So I leave the floor to Salvatore Capri, Production Area Manager for AMTS, and then I will integrate with some slides at the end of his presentation. Please, Salvatore.
Hello, everyone. Can you hear me?
Yes.
Yes.
Good morning to everyone. Thank you for your participation. AMTS is the mobility company of the municipality of Catania, which is a mid-sized town in the island of Sicily. And we are the urban road transport operator, with a yearly production of more than 7 million kilometers. This project, Best City, city is means for Catania city, contains several actions for increasing energy sustainability. I think we can go to the next slide, please. Thank you. For increased energy sustainability and decrease energy consumption in our daily activity, which is mainly to move people around city. Of course, as you can imagine, the company's main goals are the decrease of energy and maintenance costs, and the reduction of pollutant emissions by public transport. Which is our main goal, to contribute to raise livability levels of the town. Next, please. Okay. No, sorry. If we can have the previous one. Yes. These are the main actions we are implementing right now, thanks to the knowledge base we acquired through the NESOI project. So we are going to renovate the electric plant of the main bus depot and the mechanical workshop, and so reaching a total power of 5 megawatts. We are also going to build photovoltaic shelters for more than 40 bus parking spaces. In the meanwhile, we are going to implement the connection of the depot to the CNG distribution network, and to do that, we have to renovate the existing compressor. But that would allow us to enhance the vehicle refueling capacity, and will free us from taking the gas by truck. Next, please. No. The other action is we bought 18 long and 18 short electric buses, and 11 of these buses have been delivered a few days ago. So we have them in the depot, and we are going to take them on the road in a few days. So Catania will have very soon the first new generation electric buses operating. Next, please. Regarding some lessons learned, we understood the two main things thanks to this project. One is that operating transport service by full electric buses has several operation constraints, which are mainly due to the shorter range the full electric buses have with respect to the thermal engine buses, diesel and CNG. So we needed, and we need to do also in the future to carry out a careful route analysis in order to access to assess the feasibility to electric bus services of this route, and also to make some changes to the operating program of the line. The second thing we learned is that using photovoltaic energy production for direct bus recharging is obviously a challenging issue, because we have to recharge in the night, and we need and we have the production during the daylight. So it's the problem, and we need to find some technical solution for energy storage. We are going to explore also the opportunity to use hydrogen fuel cells as a technical solution, but we are studying about this. I think I can leave the floor to Giorgio for the, following. Okay.
Thanks a lot, Salvatore, for your presentation. Now I would like to move to the next slide. In this second part of the presentation on Catania project, I am presenting briefly a couple of best practices that we have adopted in supporting AMTS with this project that are related to the sizing of the e-bus fleet on one hand and on the sizing of the photovoltaic plant on the other. Regarding the sizing of the e-bus fleet, let's say, in order to overcome the operational barriers that are due to the shorter range of electric buses compared to thermal engine buses, a route analysis has been carried out in order to identify the minimum number of vehicles that are required to cover the current operational service. To do this, we needed inputs related to the description of the lines and operating service that have been collected, such as the plano altimetric variation along the line, the presence of slopes, the number of stops, the distance between two stops, the average speed, the time at each stop, operating hours per each bus, characteristics of each bus in terms of length, of weight, of number of seats, etc., and the distance between the terminal and the depot. The output of this analysis was the replacement rate between the diesel and electric vehicles in order to replace part of the existing fleet and guarantee the same service, so the existing operating schedule. Next slide, please. Thank you. The analysis consisted in the creation of a consumption simulation model for each of the lines, taking into consideration all of the inputs collected and describing the line and the service provided. The model allows to evaluate the energy consumption needed to guarantee the service, and as a consequence, the number of e-buses required. Then an optimization process was applied to reduce the number of e-buses required, and this was done based on two different aspects. One is constituted by the synergies among the lines, since electric buses can be shared on two or more lines and they are not dedicated to a single specific line. On the other hand, the fleet recharging strategies that allow charging buses when needed and not only during the night, and apply intelligent charging systems allowing to reduce the power absorbed by chargers by distributing the recharge of the individual vehicles during the time they spend at the depot. Specifically for Catania, we have analyzed 5 lines, 3 operated with 8-meter buses and 2 with 12-meter buses, replacing existing buses fueled with compressed natural gas. And to replace 21 compressed natural gas buses, 23 electric buses are required. Now let's move to the following slide, which is related to the sizing of the photovoltaic plant. As soon as the analysis of the number of electric buses, the recharge schedule was done, we knew, among other things, the amount of electricity that needed to be provided to the electric buses, and so we needed to properly size the photovoltaic plant required to produce the electricity required. To do that, we required the inputs related, of course, to the electricity demand of the charging station, which was the product of the previous step, in terms of annual, monthly, daily, and hourly demand. We needed a solar radiation database, which is available from the European Commission on PVGs, developed by the JRC of the European Commission, available online. And we needed to know if the net metering scheme was feasible according to the national legislation for the specific island. In this case, it was possible up to a certain threshold. The output of the activity was the sizing of the PV plant and the sizing of electric storage if needed. I say if needed because we will see in the following two slides the two different approaches that we can adopt if net metering is available and if net metering is not available. Net metering is the possibility for the owner of a photovoltaic or renewable power plant to consume the electricity produced by the power plant, the renewable power plant, also in a different period, in a different hour of the day, in a different day of the year, etc., than the period of production. This means that if in our case, the photovoltaic plant is producing electricity during the day, and the chargers, the electric bus chargers, are working mainly during the night, we don't need to install a battery or a storage system to store the produced electricity if it is allowed to feed the electricity produced during the day to the national grid and to withdraw it during the night. So making a balance between the production of the plant and the consumption of the site on an annual basis. So the first slide now, where we are now, is related to the case in which net metering is available. If net metering is available, we start from the annual electricity consumption of the charging station. We evaluate the average productivity of a photovoltaic plant at a specific location. So in terms of kilowatt hour produced in 1 year per each kilowatt of installed photovoltaic plant. We calculate, dividing the first by the second, the amount of kilowatt of photovoltaic plant to be installed to cover the demand, and we evaluate how many square meters of plant are required to cover such a demand. And to conclude, we identify where these square meters could be installed in the available rooftop or other areas in the site. If the installation azimuth, so orientation, and tilt, so inclination, are different than those used for the calculation done above, we reiterate the process in order to evaluate the correct peak power of the photovoltaic plant to be installed. This was the case adopted in Catania. For reference, and let's say to share an additional best practice, we have also added in the next slide the procedure to be implemented in case net metering is not available, which is not so uncommon in small islands. Of course, Sicily is not a small island, but in some small Greek islands not interconnected with the national electricity grid, net metering is available only can be available only up to a certain and relatively low threshold of photovoltaic plant power. So again, in case net metering is not available, we start again from the hourly electricity consumption of charging station. So we need the 24-hour trend for a typical day in different months, or at least in different seasons. Then, based on PVGs or on other databases, we evaluate the average hourly productivity of the photovoltaic plant at a specific location. We evaluate the size of the photovoltaic plant in terms of kilowatt peak installed required to cover the needs of the of the charging station. We compare the two curves and we determine the size of the electric storage required to match the potential supply of the photovoltaic plant and the demand of electricity of the buses. Then we fine-tune these three variables, the photovoltaic peak power, the electric storage size, and the area required for installation of both, mainly of the photovoltaic panels, but also of the batteries or other storage system. And we identify their potential location. And if this is different from the initially foreseen one, we reiterate the calculations in order to properly size the different components. This is the, the methodology we not applied in Catania, but we believed it was interesting to share it with you, since in other cases it could be applicable if the net metering approach is not feasible in the specific island. So this was the last slide on Catania project. And now we move to the third part of the webinar. So I leave the floor to Sara Ruffini from R2M, who will chair this last session. Thank you. Please, Sara.
Thank you, Giorgio. Hi, everyone. Yes, this is the last part of this webinar, and so we move on with with two questions actually. And so the first question is what are the main is about the replication. So we are I'm asking to Salvatore Capri for Catania, and then I will ask to Vasiliki Palla for Tilos. What are the main challenges, boosters for the replication that you encounter in this type of project, and that you can find for if you want to replicate these projects in another island and in similar context, but also in different. And this is regarding also, I'm asking regarding also the funding availability, on technology side, on social acceptance, but legal barriers, regulation, and so on. So I'm asking, as said, first to Salvatore and then to Vasiliki.
Okay, thank you for the question. As regards the challenges, I talked about them during the presentation. The main challenge was about the adaptation of our service program to the new requirements by the full electric buses. In terms of boosters, as AMTS, we already identified some boosters for the replication of the project. The main of these boosters is PNRR funding program by the Ministry of Sustainable Infrastructure and Mobility, which assigned almost 80 million euros to the city of Catania for the renovation of the public transport fleet and relevant infrastructures. This is one of the main funding we had in maybe the greatest funding we had in the last years, and that will allow within 2026 to buy more than 100 full electric buses and more than 20 hydrogen buses. So we will need to apply the lessons we learned about the operational constraints of electric buses to the whole service. And also we will need to replicate the electric plant empowerment and add the photovoltaic shelters for the new energy requirements, which would be almost 15 megawatts of power. So this is our new challenge we are going towards.
Thanks, Salvatore. Thank you. And this is very interesting also because in Italy we have a lot of funding available for this type of projects with the PNRR and so on, but maybe it's not the same in every EU country. So this is very interesting from this point of view because it might be easier in Italy and compared to others. So thank you. And Vasiliki, the floor is yours.
Hello. Generally, the boosters are providing a positive feedback gain for the implementation of the project. In the case of Telos, the technology adopted is considering as a mature solution, as similar interventions are widely implemented in island level. Thus, the replicability potential of the project in terms of technology is high. Another important factor that increases the replicability potential of the project is the fact that the local community has welcomed this effort made for the electrification of Telos mobility sector. Part of the municipality fleet, as mentioned before, is electrified and covers the transportation need of the local population via an e-bus during winter and summer periods, and in summer and winter periods, and this is resulting a high level of social acceptance as the project is beneficial for the residents and the local community. Generally, the project has a social character, which is reflected in the benefits of the local community, because apart from the operation of the e-bus, the excess of energy from the PV installation provides with the electricity the street lighting facilities of a central pedestrian road located in Livadia settlement, and covers also the energy needs of the municipality building, which is sited on the rooftop. Another important factor that one of the three charging is that one of the three charging stations is housed in an information kiosk, which has a name to update both locals and visitors in issues relevant with the energy transition aspects regarding Telos, which boosts even more the social character of the project. The access of both locals and visitors in the information kiosk encourages the participation of both locals and tourists in the project and increases the level of replicability as well. Moreover, the creation of a complete toolkit for the development of PV portfolios in non-interconnected islands in Greece is also increasing the replicability of the project because it helps to clarify and the process followed, as well as the appropriate documents needed in legislation and funding context. Now, however, there are constraints that one should consider regarding the sector of electromobility in island level. The following constraints are lessons learned from the implementation of the project and will contribute to the increase of replicability potential of the project of Telos. The first is that the bus trips in winter periods may be different for the summer period trips. In the case of Telos, during summer, there are more destinations added in the everyday trips of the e-bus, and thus the charging hours are increasing. There is a beach called Aristos Beach and an abandoned village, Mikrochorio, which is called Mikrochorio, and that in summer period are added in the daily trips of the e-bus. Thus, the scheduling of the charging times must be designed properly in order to meet the charging needs of the e-bus both in summer and winter periods. Moreover, the increase of the population during summer due to tourist flows increases also the transportation needs. This is also something that has to be considered in order to properly design and schedule the frequency of the trips. At this point, it is worth mentioning that in the island of Tilos, there is a recycling plant operating in an isolated area of the island by a private initiative. The daily distance that the trucks have to cover in order to collect or distribute the recycling material is quite large, as the facilities, as I said, are located in a remote place. So during my last visit on Tilos this summer, I had a conversation with an employee of this company who told me that they considering to adopt electromobility as a solution for the operation of the truck covering these big distances in order to reduce the carbon emissions on the island. This example is worth mentioning in order is worth mentioning as a potential solution like that which is in generally welcome. Could affect the capacity of EV chargers installed in the island, as the corresponding energy need will increase. Therefore, it would be useful to investigate all the future scenarios in order to be able to cover the needs of the island. Another important parameter that could negatively affect the level of replicability is the available space for parking facilities for the EVs. In the case of Tilos, the road network as well as the general geographical condition of the island are favorable, allowing the development of EV facilities and charging spots without any specific difficulties and limitations. However, in other islands possessing different geographical conditions with slopes and higher elevations, and this must considered in order to carefully design these facilities. Moreover, another lesson taught from the implementation of these projects, which will contribute in the successful replication in other islands, has to do with the climate in coastal areas. Since coastal areas have problems due to humidity. The combination of moisture in the air and the high levels of salinity, salt spray, affects the components and the cabling and the overall efficiency of the system. Thus, the chosen equipment need to have a strict anti-corrosion protection levels, and generally the implementation of anti-corrosion materials and techniques must apply in order to prevent from this phenomenon influencing the system. Summarizing what I will highlight regarding the barriers in terms of replicability potential of the island would be first the increase of the population during summer and the relevant increase of the transportation needs, the more destinations to be reached in summer period, the availability of parking areas for the EVs due to geographical limitations, and the forecasting of the future use of the EV facilities in order to avoid a potential mismatch between supply and demand, and of course the humidity issue that I tell. Okay, that's all for me. Thank you for your attention.
Thank you, Vasiliki. This was a really complete and detailed overview of the replication. So thank you for this. So we can move on to the other question and discussion that we want to to do today. So is about the key stakeholders. That what are the main key stakeholders to be engaged in e-mobility projects. So I'm asking this to Giorgio for Catania project, and to Mr. Contos for Tilos.
Thank you, Sarah. Please let me highlight how much this topic of e-mobility is connected with the other topics we are working on in NESOI, especially with the renewables topics that we will be focused of another webinar like today's one, and with energy planning topics that were already discussed in the previous webinar, since in order to shape the energy transition of the island, of the city on the island, we need to account also for electrical mobility topics, and electrical mobility, in order to be green, needs to be fed with electricity from renewable sources. So, said that, I would like to mention that important stakeholder to be involved since the beginning of the project for transition to e-mobility, especially for electric buses, like in Catania, is the energy company. I mean specifically the DSO, the distribution operator for electricity, in order to collect information regarding the status of the grid, the availability of the electrical power required at the depot, or at the location where the charging station need to be installed. Indeed, when we refer to public transport, we have to consider a very high number of buses charged at the same time, and this requires availability of high power at the same time, independently from the location of the storage. I would say it can be of the chargers. It can be installed at the depot or along the line. In any case, high power is required. Even higher power could be required for charging along the line in order to guarantee fast charging operation. And the availability of power strongly influences the feasibility of the project and the profitability of the project, since if this high power is not available, additional investment costs need to be considered to adapt the grid and the electrical substation. Also, with reference to the installation of new renewable power plant, we need to discuss with the DSO, with the National Energy Company, in order to check, as I was mentioning earlier, the availability of net metering, which, if is not available, requires different sizing of the PV plant, typically larger, and also the installation of a battery or another energy storage system, which introduces additional investment costs that can constitute a barrier to the realization of the project in financial terms. So I would like to stress the need to involve the electricity distribution operator since the beginning. That's it from my side.
Thank you, Giorgio. And so now I'm referring the same question to Mr. Contos.
Hi. Our niche is probably the same as in Italy. Who is going to engage? The municipality is going to do all the work. In order of consulting, we are going to use the University of West Attica, but all the procurements and everything is going to be from the municipality, and all the charging station also are going to be from the municipality. In the involvement is going to be the national power distributor in order for the net metering scheme to tell us. We're trying to find a solution with them to be over the 100 kilowatts, because I know it is going to be bigger, because as Vasiliki told you, there is very much interest in going in mobility in the whole island. The municipality is one step ahead, but everybody that's come wants to know if we have charging station in order to start buying electrical vehicles.
Okay, thank you, Mr. Contas. And so I think this was a really interesting discussion, and so we learn more about the project, both in terms of replicability and also for the key stakeholders. And we saw two different situations between Italy and Greece. So I think that's all from my side. I think the words now goes to Cecile for the wrap up.
Yeah, Giorgio, do you want to do a technical wrap up?
Okay, thank you, Cecile. I don't know if there is any question from the attendees online.
Checking. No, nothing posted online.
Okay, thank you, Cecile. So just to wrap up and close the webinar, I think we have seen this morning two different aspects related to mobility. One is related to some theoretical aspects on how projects for e-mobility need to be shaped in order to be successful on islands. And this is related to the sizing of the vehicle charging infrastructure, the replacement rate between conventional vehicles and electric vehicles, also the opportunities and how they could be exploited for the replacement or the conversion of existing ferries to electric ferries. And on the other hand, what is needed from the energy side to ensure that energy transition opportunities for mobility are green and aligned with sustainability targets at EU, national and international level. So what we need to do for the production of electricity from renewables in order to supply energy to electric vehicles. We also have seen some examples of how this has been implemented in different contexts, both in smaller islands like Antiparos and Tilos, and in larger islands like Sicily, where Catania is. I invite all of you to share questions on the chat now, or even after the webinar via email to NESOI contacts, and to keep in touch with NESOI media, website, LinkedIn, and other social media in order to be informed about the other webinars that we will organize to share the knowledge we are generating thanks to the technical and financial assistance we are providing to European islands in our project. So thank you very much for attending this webinar. Thanks a lot to all the presenters for sharing their views and their experience. And let's keep in touch and have a nice day.
Thank you, everybody. Thank you for your participation.